Hey there, builders and makers. Let's talk about functional dimensioning in mechanical drawings. It's the secret to making sure your parts fit together. Functional dimensioning focuses on the dimensions that matter for a part's function. Imagine you're building a robot arm. You wouldn't just start welding pieces randomly. You'd need a blueprint with precise measurements. That's where functional dimensioning comes in. It's like highlighting the most important measurements. For example, a shaft fitting into a hole. Functional dimensioning focuses on the diameter of the shaft and hole. These are the critical dimensions for a proper fit. It's about focusing on what matters most so your project comes together smoothly. Why is functional dimensioning so crucial in the world of making things? It's a game changer for several reasons. It ensures your parts fit together and work harmoniously. Misaligned parts can lead to jamming mechanisms and frustration. It acts as a roadmap for the manufacturing floor. Highlighting essential dimensions guides their priorities. It works hand in hand with geometric dimensioning and tolerancing, or GD and T. GD and T ensures consistency and interchangeability of parts. Functional dimensioning saves time and money without sacrificing quality. And who doesn't love saving a few bucks? Okay, so we know functional dimensions are important, but how do they differ from non-functional dimensions? Let's use a mounting plate as an example. Imagine a rectangular mounting plate with 4 holes for attaching it to a wall. The functional dimensions would be the distances between the holes. These dimensions are crucial because they dictate how the plate aligns with the corresponding mounting points on the wall. Now, the overall length and width of the plate might seem important, but they might not directly impact its core function, mounting securely to the wall. These could be considered non-functional dimensions. They matter to an extent, but slight variations might not be detrimental to the plate's purpose. Here's the takeaway. Functional dimensions directly impact fit, function, and assembly. Non-functional dimensions, while still important, offer more flexibility and might not be as critical to the part's primary role. Identifying this distinction is key to efficient and cost-effective design. Section 4, Applying Functional Dimensioning, a step-by-step guide. Ready to put functional dimensioning into action? It's like building a rocket, exciting and methodical. Let's break down the process into manageable steps. Step 1. Get to know your part inside and out. What's its main job? How does it interact with other components? This understanding is crucial for identifying the dimensions that truly matter. Step 2. Pinpoint those critical features. These are the elements that directly contribute to the part's function and its ability to mesh seamlessly with the rest of the assembly. Step 3. Let function be your guide when adding dimensions to your drawings. Instead of just measuring everything, prioritize those dimensions that directly impact how the part works and interfaces with others. Finally, don't forget our good friend GD and T. Once you've identified the functional dimensions, apply GD and T to provide clear tolerances and ensure consistency in manufacturing. This dynamic duo, functional dimensioning and GD and T, is the key to manufacturing success. Section 5. Mastering functional dimensioning, a path to cost savings and quality. Mastering functional dimensioning is like having a superpower in the world of design and manufacturing. It's about working smarter, not harder, and reaping the rewards of efficiency and precision. First and foremost, it's a cost-saving ninja. By focusing on the essential dimensions, you streamline the manufacturing process, reduce waste, and minimize the risk of errors that can lead to costly rework or scrapped parts. Think of it as optimizing your design for efficient production. Secondly, functional dimensioning is your secret weapon for achieving top-notch quality. By clearly communicating critical dimensions and tolerances, you empower manufacturers to consistently produce parts that fit and function as intended. This translates to happier customers and a solid reputation for your products. Moreover, it fosters better communication between design and manufacturing. By speaking the same language of functional dimensions, both teams can work together more effectively, minimizing misunderstandings and reducing the potential for errors. Clear communication is the cornerstone of any successful project. Section 6. Conclusion: Functional dimensioning in the future of manufacturing. As we hurtle towards a future driven by automation and advanced manufacturing techniques, functional dimensioning remains a timeless principle. It's the bedrock of efficient, cost-effective, and high-quality production. Embracing functional dimensioning is not just about adding numbers to a drawing, it's about adopting a mindset of clarity, purpose, and precision. It's about understanding that every dimension tells a story, and by focusing on the most critical chapters, we can create products that truly work. So, let's get out there, embrace the power of functional dimensioning, and build a future where every part fits perfectly, every mechanism operates flawlessly, and every product exceeds expectations. Remember, it's not just about building things, it's about building them right.